Okay, so this is going to be a summary video on percentage yield, talking a little bit about what it is and then one worked example. So percentage yield is comparing the amount of product that you actually make compared to how much you should have been able to make based on your balanced equation calculations. So for example, when you take two reactants, react them together, you make some product. Now the total amount of green product is how much you should make, but often you make less than that. And there are numerous reasons why that could be. It could be temperature, you might have impurities, you might have lost some material in transferring, but there are many reasons. You need to be able to determine when you do this reaction how much you're going to make compared to what you did make, so that you can accurately predict each time you do the reaction, how much product you make. And so in this case, the percentage yield is about 75%, which is actually quite a low yield. So the equation for percentage yield is given there in that box. Your percentage yield is equal to your actual yield, how much you really obtained at the end, divided by your theoretical yield multiplied by 100. You don't need to remember this equation because it is given to you in the data booklet on page 4 or page 3, I think. Now I'm going to take you through an example of the most difficult type of percentage yield question. This is where you're only given information about the reactants and then having to go through all the steps. Often percentage yield questions are broken down into parts, and you might only need to do one or two of these steps, but I'm going to show you all four. So the first few steps are just a normal calculate how much product based on the reactant. So a normal mole calculation. So step 1, calculate your moles of limiting reactant. You're usually told which one that is. Use mole ratio to work out how many moles of product are formed. Calculate what mass that would be, and that's your theoretical yield. And then use your actual yield, which will be given to you in the question, to calculate your percentage yield. So we're going to do a worked example using all four steps. Okay, so we've got a question here. 2 grams of methyl ethanoate, that was just me choosing the color of my pen, was formed when 4 grams of methanol reacted with excess ethanoic acid. So ethanoic acid is in excess. Ethanoic acid is obviously this carboxylic acid, so we don't need to worry about that, it's in excess. So that means that is our limiting reagent. That's going to be our methanol, and this is going to be our product. Now, typically in a question like this, they're not going to ask you to calculate the GFM, they usually give it to you. So the GFM of methanol is 32, and the GFM of that methyl ethanoate is 74 grams. Step 1 is calculate the moles of your limiting reactant. Now, ethanoic acid was in excess, which means our methanol is our limiting reactant. So we are working out moles. We know that there were 4 grams, so N equals M divided by GFM, which is going to be in this case 4, which we've taken from here, divided by 32, which has come from here. That's 1/8, which is actually a nice number. It's 0.125 moles. So step 1, quite easy. Our second step is then to use the molar ratio to work it out. Now, most questions that they do are actually this type of reaction. It's known as an esterification. You learn about it more in Unit 2. It's usually a 1-to-1 ratio. So our ethanol here, that was a 1, that was a 1. And so this number of moles was 0.125, which means we've also got 0.125 moles of this. And it's usually a 1-to-1 for this, but it's not always going to be the case. So that's very straightforward. We can then move on to step 3, which is work out the mass of product. Now the mass of product, these slides made a mistake. That was 74, not 32. So we're trying to work out a mass, and that's going to be our number of moles multiplied by our GFM. Our number of moles is 0.125 from our mole ratio, and then we've got 74 here. And whenever we do this, we end up with 9.25 grams. That is our theoretical. Okay, so if you had to calculate it, it's your theoretical. So we have 9.25 is our theoretical yield. And finally, we're going to use our equation here to calculate this. So our actual yield, you have to go back to the question. That's how much was made. So our actual yield was 2. Our theoretical yield was 9.25. And we multiply it by 100. Now, whenever we do this, we don't get a really nice number, so we round it. And in chemistry, typically round it to 2 decimal places. And this is 21.62%. You can see it's relatively straightforward. It's just a normal mole calculation, and then we just do this as a final step at the end. They can sometimes give you the percentage yield and then ask you to work out the actual yield. So all you would be doing there is reorganizing the equation in order to make that work. Okay, so hopefully that's a nice refresh and quick go over how to do percentage yield, and it now makes a bit more sense.